For most, starting this journey is a result of business initiatives that have driven us to think about software in a new way. 500 million new applications are going to be developed in the next 3 years. That's more than all the software development we've done previously. And that's a result of us rethinking how we approach our business strategies and how we think about leveraging software as a differentiator for accelerating new opportunities. So whether you're starting in the CIO's office and thinking about agility and staff productivity or new customer experiences that align to your business outcomes, or whether you're the chief security officer thinking about security and compliance and how to scale quickly while maintaining your resilience and expertise around security, or the owner of your big data platforms, where you can really bring in new technologies like AI and ML, or develop capabilities around data transformation, or the head of infra and ops, where you need to think about your cost for your existing application landscape, your existing infrastructure, the number of vendors that you've been dealing with for the many years you've been managing that application portfolio, and the supply chain that is going to constantly need additional capabilities and additional value brought to it. For all of these stakeholders, the application modernization journey brings a ton of benefits. And it's with that in mind that we know that this journey is aligned for all of our stakeholders. But the key is making sure all of our stakeholders are aligned on how we progress through that journey as much as the outcomes of that journey. But let's start with where we are today. We know that in today's world, it's hard to get features developed and released into production. We have long release cycles. We have development that's been stalled for months, sometimes years, waiting for deployment. We have operational inefficiencies in our existing environments as a result of overhead that we've accumulated over many years, the acquired tech debt of legacy infrastructure and mismatched software and hardware, all tied to a very slow hardware development lifecycle, has forced us to think about our application stacks in snowflakes. And then add to that the inability to then support changing compliance and governance regulations so that we can no longer address security proactively. We're completely reactive in how we think about security. All of these factors have had impact to our business, whether it's missed opportunities and lost revenue, lost productivity within our teams, and the inability for us to train our teams and get them upskilled so that they can get past the undifferentiated skill set that they've had to use to maintain the existing portfolio, or whether it's fines for non-compliance or reputational impact of security incidents. All of these things have prevented us from moving forward on this journey, and these are things that are holding us back from making that forward step to building the next applications. So these are the things that we have to fix in order to make sure we can get to the next set of applications that will really drive the business forward. Now that we understand where the challenge is, let's talk about where some of the solutions are. This is what good looks like. In a modern development practice, developers can request infrastructure quickly. They get their deployments done in minutes, not weeks or months. They can get sandboxes for individual test environments or for innovation and high velocity development. Software delivery is a continuous pipeline. It's not manually ad hoc deployed by individual teams or individual users. Security is not bolted on after the fact. It's not part of the network and part of the host and trying to infer what's going on within your application. It's built in as a part of your application, and it's a built-in part of your practice for software development. And observability becomes part of the software development lifecycle. We instrument as we go. Instead of waiting for things to break in production and then going back to find out we didn't have the right metrics measured or we didn't have the right logs or traces input into our application to determine where the problems were. And tooling starts to become consistent. We're not using different tools for different stacks. We're using consistent tooling so that we're no longer focused on how do we manage or maintain this one application, but how do we manage and maintain across our entire portfolio and not just the single stack that may be broke in production. Now, the benefits at the end of this journey are massive. So for each of your stakeholders, they're going to see a benefit that speaks to them, whether it's the 409% ROI over 5 years, or the 43% fewer security incidents, or the 89% faster compute deployment and 3 times as many features delivered per year. Everybody gets a benefit. These studies done by IDC showed that customers who embarked on this journey, and even as they continued through this journey, got this payback very, very quickly, 9 months, which is unheard of in our industry. So it's important to see that that investment you make today will quickly pay off and be a benefit to all the stakeholders we talked about. Now, there's a couple of paths that you can take through this application modernization journey. And we want to lay out some of the best practices that we've formed as we've seen thousands and thousands of customers go through these paths. There's some key patterns that are repeatable, that you can use and embrace, and that will make sure you're successful in this process. The first is thinking about how you modernize existing applications. We'll talk a little bit more about how you take an application that's already available for you to modernize and move it into a cloud environment and get the benefits of cloud managed infrastructure. We'll talk about how you build new for applications where you have no technical debt, where you have no way to look back, where you can start from scratch. And then we'll talk about how we accelerate through this journey using DevOps. Let's start with some of those existing applications and the benefits you can see from moving into a cloud environment. The first question you have to ask yourself is, how much infrastructure do you really need to manage? This is a key question. Deciding on whether managing infrastructure, whether it's at the server level, the operating system, or in today's environment with containers and a container orchestrator, asking yourself this question will decide whether it makes sense to invest in managing that infrastructure and getting benefit from it, or whether it makes sense to outsource as much of that management as possible. The cost and expertise needed to manage this lower level infrastructure, we've all decided for server real estate, for hardware, doesn't make sense for most applications. Not all, but typically most. As we move up the stack and as we look at the additional layers of abstraction that are available to us, whether they be containers or whether they're event-driven functions with serverless technologies like Lambda, you can decide for each application, for each team that you work with, how much that management is worth to you. And that decision typically begins with compute, but is not the end of that decision. So there's a lot of options around compute, and you can outsource as much or as little as you need to for the given application or given workload that you're looking at. Starting from Lambda, where all you bring is your application code and AWS manages the rest, down to Fargate, which takes care of the underlying infrastructure and takes care of operating system instances, your patching and lifecycle around the infrastructure, or moving further down into our container offerings with ECS and EKS, where you can take advantage of our managed control planes so that you no longer have to worry about making sure your container platform is running or adhering to best practices, down to eventually EC2, where you can take advantage of some of our offerings that get you dramatic cost savings like Graviton and Spot. Depending on your workload, depending on your team, and depending on your software development maturity, you can decide which of these capabilities is right for you. And in some cases, it's a combination. It's never just one technology, it's usually multiple. Let's talk about 3 strategies, though, in which you can use these technologies. The first is re-platforming your existing workloads. So you may already have taken some of your workloads and containerized them. You've taken some of that legacy application, you've turned it into a container so it's more portable, you can easily develop your CI/CD pipelines around it, but now you're managing your container platform, maybe on-prem, maybe in EC2. You can quickly take advantage of our managed container offerings to ensure you get lower direct costs and to reduce that operational overhead. Managing a container control plane is not for the faint of heart. There's a lot of work that happens there, and many of the teams we see who have been managing their own environments spend 60 or 70% of their time just making sure the environment is running, whether that's keeping up with new versions of the orchestration platforms, whether it's ensuring that your logging and monitoring tools are integrated correctly, or making sure that your best practices are implemented and maintained. Each of those requires effort from your teams. Using a managed control plane allows you to reduce that operational overhead while increasing your resource utilization, increasing your security posture, and increasing your flexibility as you grow and scale those workloads. The second path you can take is to refactor. Now, in most cases, you've got an application, a legacy application, that you want to break apart into smaller microservices. That helps your teams manage the application better. It helps them individually innovate so that they can take advantage of areas of innovation around each part of the application rather than trying to re-architect or rebuild the application from scratch. Now, the advantage of refactoring is you can take smaller parts of your application, break it out, build it, and that allows you to lower the risk of trying to re-architect or rebuild the application from scratch, where you might miss a feature or miss a capability or be impacted by architectural decisions that had unintended consequences. By doing this refactor, you're able to take advantage of our best-in-class security capabilities, and you can reduce your total cost of ownership using capabilities like serverless with Fargate or Lambda. You can then decouple the organization as well. So you can slowly innovate out with those teams, those services that have been refactored. And as you slowly migrate more and more pieces out of your legacy application, you will have transformed not just your legacy app, but also the organization around it. So this strategy allows your teams to move independently, but also reduces the risk of something going wrong as you innovate in parallel. Delivery Hero is a great example of one of our customers who was able to do this. They took it upon themselves to develop their migration initiatives to drive a better outcome for their application. They slowly decomposed a large monolith application onto Kubernetes and were able to transition all of their workloads in 6 months. This resulted in a huge cost savings on their infrastructure as they took advantage of EC2 spot instances as well, allowing them to get a 70% cost reduction in their overall infrastructure usage, and then allowed them to scale out to the 43 countries in which they do business to provide delivery services. This allowed them to also ensure they were following their best practices. So Delivery Hero took advantage of the ability to re-platform and refactor and ensure that they got the cost advantage and flexibility that went along with it. Now, let's look at new applications that you can build from scratch and how you take advantage of some of the technologies we have at AWS. To build new applications, you want to ensure that you have rapid time to market and that you can experiment. You can do this because you've got no legacy, so you can start from scratch. This allows your teams to focus on productivity and agility and focus on the business logic, not the infrastructure. The goal here is to make sure your teams are spending time building and innovating rather than spending time building out a common platform. One way to do this is to build out a shared services platform that incorporates all of the necessary capabilities needed to build out an application, whether it's logging and monitoring, CI/CD integrations, API governance, cost management. All of those capabilities together, you can build into a single platform that they can tenant all of their applications on, or you can build a blueprint that they can take advantage of and run as an independent environment. This is one of the easiest paths, but it's also fairly risky. It means that you've got to make sure you've got enough executive sponsorship to ensure that if you need to pivot or if you need to rethink your application architecture, you have the support to do it. So it's important to think about how you're going to approach this, not just from the technology standpoint, but also from an organizational standpoint. Are your teams ready to support you in new operational models, new development models, not just how you're going to develop the app? SSP allows you to maintain those guardrails and make sure that you've put that platform in place that your teams can take advantage of and not have to spend time redoing. Coca-Cola is an example of one of our customers who is able to think about developing a brand new application. And they did this in the middle of COVID. So as a part of their move to develop a touchless payment system for their freestyle drink dispensers, they wanted to develop a smartphone app that allowed customers to interact with the dispenser, but without having to come in contact with the actual vending machine. So they were able to launch an app prototype in 1 week. This was during COVID. And within 100 days, they developed the app and then scaled it out to 30,000 machines using this touchless capability. They got an increase in their buying interest from customers, a 50% increase in that buying interest, and a reduction in their delivery time as they ideated and developed this app. So this is an important way for them to think about how they could build their next application and then scale it out quickly. In just 150 days, they scaled out to over 10,000 machines and now scaled out to 30,000. Lastly, let's take a look at how you can use a DevOps model to accelerate change in your organization. Organizations have applications sitting not just in AWS, but all across their infrastructure, whether it be on-premise or in other cloud providers. And we've got a variety of capabilities that allow you to make sure you have consistent management across your real estate for provisioning, for operations, for governance, and observability. And this is important because this is how you'll scale out as you build out those next applications or as you replatform or refactor any of your applications. To do this, a shared services platform, as we talked about, is one of the best ways to build out that functionality. With an SSP, you're able to build in all the key integrations and all the key operating capabilities for an individual environment and for a group of applications. So with an SSP, you're able to take advantage of hyperscale and growth while not rebuilding that platform over and over within each of your development teams. Now, this is what modern operations should look like, and this is how you really want to go to accelerating your modernization journey. Those who go down this process do so through automation. And automating is the key way in which you get through to a new application paradigm and new development paradigm. Those who implement this software delivery with continuous delivery and fully automated are 3 times more effective at managing their change management, are able to restore their services in less than 24 hours, and fully able to remediate security vulnerabilities in less than a day. And it's even likable for some of their employees. So you can imagine as you roll out capabilities that make the life of a developer that much easier and automate away the tedious hard work of just ensuring that tests are run or that observability is built in from day one or security best practices are implemented, more and more people will come and innovate with you on that platform. And you can do this by implementing a set of tools. Now we have a number of these tools available in AWS to help you go from authoring your source code all the way through to deployment and monitoring and managing. And all of these capabilities allow you to automate that individual part of the process. It's important for us to point out, however, that we are absolutely 100% supportive of also using third-party tools as a part of this process. So you can take any of these tools as you see fit, and you can go ahead and replace it with a third-party tool that you feel provides you the necessary capabilities you need as well. What's important here is that you build the end-to-end CI/CD pipeline. that it's continuous, and that it's fully automated. Do that for your applications as well as the rest of your environments, your configurations for your clusters, your orchestrators, and the rest of your operations, security, and observability. The benefit to treating all of your operations, your configuration as code means that you have a repeatable environment. Treat everyone as if they're a software developer. Take their designs, take their code, store it in a source code repository, version it, control it, make sure it's a repeatable and automatically deployed process. That removes all of the config drift out of the system. It makes sure that you have the observability and governance always included as a part of your rollout. This allows you to make sure your teams are providing capabilities that are fully repeatable and automated, and it keeps all of your teams in sync with what's running in production. So whether you're managing clusters or instances or your applications, make sure it's written down as code. So now let's take a real life example of this. One of our customers, Fidelity Investments, took it on to modernize their mainframe applications using AWS Lambda.
We're going to go over the decision to go serverless. We're going to look at the high-level architecture of the services used. We're going to then review our achievements and talk about our lessons learned. And then finally, we'll wrap up with what's next. So what is Fidelity's tax real-time cost basis engine? So it is the engine that supports the regulatory requirements to create and manage tax lots and position cost basis. An example can be seen below. So in this example, it's a simple buy and sell example. We have a customer in the first stage initiating a buy request for stock XYZ. When the buy order comes to Fidelity's tax system, we will create new tax lot for those 10 shares that the customer bought at a price of $50 a share and a basis of 500 in this example. We will also try and look for positions that have been created previously. And if a position does not exist previously, we will create a new position cost basis for that particular position. So you can see in this case, the position created was the same 10 shares at a total basis of $500 and a per share basis of $50 a share. Later on, the customer sees that the stock price has declined from $50 a share to $25 a share, and has decided to buy more shares of this security in dollar cost average. So we create a second open lot for that second order. And in this case, you see lot 2 for 40 shares at $25 a share with a basis of $1,000. We'll also take that information and go to the position cost basis and update it along with lot 1. So now you have a total position basis of 50 shares with $1,500 as your total basis and a per share basis now of $30. At another point in the future, the customer decides, hey, I want to actually sell some of these shares because the stock has gone up to $100 a share. So when a sell order comes through, we actually create what's known as a close lot. So we manage both open and close lots in our system. And you can see at the bottom, the close lot of 5 shares for $100 a share with a proceed of $500 and a gain of $250. So when we actually create the close lot, we also have to modify the open lots that existed previously. So you can see, because we're using a FIFO method, or first in, first out, these shares are actually decremented from the first open lot. So you can see now lot 1 has a quantity of 5 shares instead of the previous 10. We've also gone over to the position and modified the cost basis, because now you own 45 shares instead of 50. You have a different total basis and a different per share basis amount. So this is just one simple example of a customer performing buys and sells for a given security within their account. We have millions of customers at Fidelity Investments, all have one-to-many accounts, all have one-to-many positions, all have one-to-many lots that all have to be managed through our system. Buys and sells are just one way that we actually manipulate lots and maintain your cost basis. Another way is through corporate action events such as dividend reinvestments, stock splits, mergers, acquisitions, etc. So we have many different ways we have to manage this information and provide it for our customers. Now, the decision to go serverless. So how did we make this decision? We started with the 6R analysis and looked at whether we wanted to re-architect this natively in the cloud in AWS, or do we want to rehost it leveraging containers? And by the nature of this application being a transaction processing application, and it's actually asynchronous in nature, we felt that it was a great fit to leverage some of the serverless capabilities. We also looked at the expected benefits of serverless versus containers, and we wanted to take advantage of some of these expected benefits. A much higher cost savings, much lower maintenance, greater degree of modularity, resiliency, and elasticity. We also had our leadership team at Fidelity for this particular domain be very forward-thinking and looking at these capabilities and deciding that that was the right fit for this purpose. We also took out any regulations that we may have had, whether or not we can go to the cloud for this application, and look at any policies or contractual obligations that may have prevented it. In this case, it did not. And then this wasn't the first application to actually go serverless in Fidelity, or even within FBT, our Fidelity Brokerage Technology Department. So we were able to leverage some previous experience and lessons learned from those other groups and pull them in as needed when we ran into any issues. Now, we also wanted to take a look at how do we minimize our vendor lock. So a couple of ways that we implemented this through our project was to first separate the business logic and infrastructure integrations. This provided us a capability that we were able to automate our testing before we actually deployed our application to the cloud. But it also enabled us to easily pivot to containers for our business functionality if we need to, and or if we also need to look at pivoting to another cloud service provider, we have that ability easily as well. We wanted to leverage similar infrastructure components across providers. So when we chose which capabilities in AWS we were looking at, we also wanted to make sure that similar capabilities, although they probably will behave differently, existed in other cloud service providers, so that if we needed to pivot, we could, and we could take advantage of similar capabilities. And finally, we wanted to leverage portable frameworks and languages. We didn't want to tie ourselves into specific languages and frameworks for a given cloud service provider. We wanted to leverage tools that we can enable across all. Moving on to our high-level architecture. So in this diagram, you can see the transaction flow on the top, where we get our trade events, like we mentioned previously, with the customer doing buys and sells. Those trade events come into our platform, and we leverage tools from AWS, such as Lambda, for our compute environment. DynamoDB is our backbone for our event-driven architecture flow, as well as our data store for our transient data. We call out to external APIs as needed, and we leverage SQS to throttle those calls so that we don't overload those external resources. We also enable replays, dead letter queues through SQS as well. We have S3 for object output, so as we create those cost basis and positions, the lot information, we store that into S3, and we can then leverage that to distribute to our downstream systems. We also leverage step functions in the bottom. So we have a batch process on-prem that works and creates additional information that we must source and store into AWS. So we use the step function orchestration capability, as you can see, to parse, split, and load into Dynamo in parallel. And then ultimately, the data on the far right is distributed to external systems through messaging infrastructure or stored in a relational database that can then be pulled through our API layer. As far as goals achieved, going back to those expected benefits. So we are executing 35 million Lambda executions per day on a normal trading day through this platform. We have achieved our elasticity to support our peak volume and beyond. So instead of on-prem worrying about our capacity, now we worry about the external integrations and how we have to throttle down to integrate with those. So we get that elasticity of the cloud for our platform using the serverless capabilities. It's a highly resilient platform across multiple availability zones. We are also replicating this data to multiple regions in case of any regional outages or failures. It's extendable for future benefits. So we are actively working on additional business capabilities to support new offerings from Fidelity, and we'll be extending this platform very shortly. And it's very minimal maintenance. So we no longer have a lot of maintenance work like we did on-prem, and we can focus on achieving the business value. As far as cost benefits go, we are delivering about 75% or so infrastructure cost savings compared to our on-prem compute environment. We are making use of efficient AWS infrastructure. For example, tuning each Lambda function for performance settings and cost benefits. We have very low cost in non-prods and prod after hours. So on weekends, our costs are very minimal and our non-prod environments are very cheap. And we're also making use of future enhancements to deliver additional savings, such as AWS's recent release of the Graviton processors. As far as our lessons learned go, first, automate everything. So at Fidelity, we have the requirement of automating our infrastructure as code, our pipeline as code, our functions, obviously, and our test automation. We don't allow our teams to go into the console and deploy applications into production. So it is a requirement that everything is automated. But that is very beneficial as we need to spin up environments on the fly. Also admit that architecture and delivery in an agile fashion will change over time. So we designed this application initially, but as we got into each component area and came into the requirements of the application, as well as the capabilities of the infrastructure, we adjusted and pivoted and decided on different types of implementations throughout the project. Like I mentioned previously, we integrate with external APIs, and we also integrate with external data sources, where we have to design for those inelastic integrations. So we get native elasticity out of the box for our platform, but as we reach out to some of these other platforms, perhaps we have to throttle ours back in order to not overload them. We get the built-in resiliency and observability to fit our application requirements. We leverage available knowledge base in external and internal resources. So we have, like I mentioned previously, we have other applications that have gone to the cloud, and we could leverage those teams. We also have centers of excellence in Fidelity that have helped us along the way. We have resources from AWS that we've worked with as well, and even relied on and partnered with external vendors for our design and delivery as needed. Also execute in prod parallel. So we spent a couple months at the end of this project executing both in AWS and on-prem, comparing output and adding requirements and adding stories to our backlogs to address any of the differences that we experienced between the platforms. This was very beneficial for us to make sure that we're producing the same output that we produced from our legacy application in the cloud. And finally, plan for education, pivots, and delays. When we started this project, it took about 18 months to go from beginning to end. We started with one Scrum team and ended up with 3 with multiple other people helping along the way, especially at the end, to get us to production. We ran into obviously learning and growing and changing and making design decisions and making delivery decisions throughout the project that ultimately enabled us to be faster and more nimble, but did take time and enhanced not only our quality of work, but also the timeline. What's next? So for us, we plan on a continual evolution of our real-time cost basis platform. We will be rolling out new features, like I mentioned previously, for new business products. And as tax law changes, we'll have to make sure that we incorporate those changes into the platform. We will look at AWS additional capabilities, like previously mentioned, the Graviton processor and Lambda, and even the new integration options from step functions and our orchestration. Our batch engine that exists on-prem will need to be re-architected into the cloud. And our database that's currently on-prem that we source all of our data to will also have to migrate out into the cloud. And finally, new applications leveraging serverless architecture. We have multiple tax products in our domain that are looking at this similar architectural styles and are looking to implement them very shortly. And beyond tax, we have other domains based on a fit for purpose that are also looking for how to leverage serverless architectures. So thank you for your time today, and I hope this information is very helpful for your journey into serverless, modernizing your applications.
Thanks, Mark, for your insights on your modernization initiatives with the mainframe, moving it to Lambda. Let's recap what we heard across the entire talk. If you're starting your modernization path by building brand new applications, look to use the highest level of abstraction you can with serverless capabilities like Fargate and Lambda. By building an event-driven architecture, you can hand over as much of the infrastructure management, the resiliency, the security, the uptime capabilities, as much as you can to the provider, and make sure your team gets to focus on innovation and building those next 500 million apps that are going to come in the next 3 years. If you're looking to re-platform existing applications, look to where you can leverage managed services. With managed container services, you can lower your operational cost to managing that control plane and making sure that your team spends time on building out supporting capabilities and building in the CI/CD pipeline and logging and monitoring and observability functionality, rather than trying to just keep the container platform itself up and running. If you're refactoring an existing application and tearing it down and trying to build out components and pieces, think about how you use that opportunity to modernize both the architecture, as well as think about how you're going to up-level your teams so that they can be focused on software delivery and new modern operations, as well as data management. That's going to help your teams level up, and it's going to make that modernization journey much more successful. And have your executive sponsorship ready to ensure any decisions you need to rethink along the way or you need to pivot are supported by your executive. And then lastly, as you look to scale out your modern operations, look to build out a shared services platform. That's going to provide the consistent tooling and governance and guardrails to ensure that you can scale your operational model and allow your teams to focus on building their applications rather than building up the container platform itself. It's going to accelerate not just your development teams, but also your infrastructure teams, your platform teams, and anybody else who's supporting that platform. Thank you for your time today.